Greetings and hello. I want to have a closer look at trigonometry. There's something wrong with what is taught in schools, at least the depth at which it is taught. This is the ubiquitous circle, as you can see, and looking at trigonometry, the ratios that we look at are called sine, cosine and tangent. So we have sine, cosine and tangent. I've abbreviated them there, but these are the identities that we might be dealing with. Now, a sine, if you look at it graphically, is a curve. A cosine is the complement of the sine, equally a curve. A tangent is a curve. It's more complex and it's different. But these are all curves, and I wonder how you can relate curves to a right angle triangle. If you can spot a curve there, I'm very pleased for you. I know that a ratio, the ratios here will give you sines, cosines and tangents, but it doesn't seem to relate to triangles at all. It seems to me to relate to only the circle. For instance, y is sine 90 degrees 1. Y is sine 180 degrees 0. Because if, as you have been taught, the trigonometric ratios are represented by SOHCAHTOA, not everybody's been taught this. I met a student last week who had never heard of this, and he was in his mid-20s. Anyway, what we're saying here is that, let's just look at sine. Sine, the sine of an angle, equals the length of the opposite. Let's say this is the angle. The length of the opposite over the length of the hypotenuse. Hypotenuse means long side, opposite is obvious what it means. Now, if we have a triangle whose opposite and hypotenuse are the same length, it's a straight line. Not a triangle at all. How can it possibly be? If the opposite divided by the hypotenuse is 3, 6, 9, I don't care. If opposite is 1 and hypotenuse is 1, the answer is 1. There. No triangle. The triangle doesn't exist. Let's have a look at 180. 180 is the opposite direction. In this case, the opposite is the opposite over the hypotenuse. The opposite is 0. Now, if you have a number, a fraction like this, where the numerator, the numerator here is 0, then the answer is going to be 0. 0 divided by anything is 0. Once again, no triangle. Where's the triangle? I can't find one. What we need to do is to work back, in my opinion, to here, which is 360 or 0, and the sine of 360 and 0 is also 0. We're not talking about triangles. We're talking about circles. These are curves. And we need to get into that before you can move any further. If you're going to go from being taught that trigonometry has to do with right angle triangles and then go on to study maybe the calculus and deeper and higher maths, you need to understand what the route is. Schools far too often teach the shortcuts, teach the facts, but not the reasons. Now, I'm just drawing some radiuses here. I say radiuses, not radii. I don't speak Latin. And what I'm going to do is to look at the only way I can get this circle and this radius into being a triangle is to drop a line from the circumference down to the radius. But this is no longer the radius, because that is the radius and this is shorter than the radius, so it can't be the same thing. So this is a radius, okay, or you might call the radius now the hypotenuse. And we've dropped a line down to 0. And this is now a right angle triangle. And this is the angle we're concerned with, theta. Now, we've moved round a bit, and we've dropped another line down here. I'm sorry if this is starting to look complex. And we've got another right angle triangle. And what's happening here is that the opposite side, the hypotenuse remains the same. The opposite side is getting longer, and the adjacent side, the A in SOHCAHTOA, is getting shorter. And eventually, when we get up to 90 degrees, the length of the adjacent side will be 0. And therefore we have 1 over 1, but it's no longer a triangle. Okay, where do we go? Well, we have to consider that trigonometry, which means 3-side measurement, is much more related to a curve, and in this particular case a circle, than it is to the triangle. I believe if you start from the concept of sines, cosines and tangents being curves, and they must come from circulars, any curve really, if you look at calculus, but they don't come from, trigonometry does not come from triangles, trigonometry comes from circles. Thank you.